So it is my great pleasure to introduce today's keynote speaker, Professor Patricia Lago from the Vrije Universiteit Amsterdam in the Netherlands. So Professor Lago is internationally recognized for her pioneering work at the intersection of software engineering and sustainability. And she leads the Software and Sustainability Research Group at VU Amsterdam. Her work focuses on software architecture, quality, and sustainability with a strong emphasis on real-world impact. And she has collaborated extensively with partners from industry and public sector. For example, co-founding the Green Lab, a place where researchers, students, and companies can collaborate together to measure the energy footprint of software solutions. And Professor Lago has received a long list of awards. For example, she was awarded an honorary doctorate by the Norwegian University of Science and Technology for her scientific leadership in software sustainability. And she is also the recipient of the IEEE TCSE New Directions Award in recognition of her pioneering work in sustainable software, where new dimensions of software engineering with enormous impact on society, such as e-waste and software energy efficiency, are considered in the software engineering process. And most recently, she received the IEEE TCSE Diversity and Inclusion Award at the 2025 International Conference on Software Architecture. And she will be giving her keynote on software sustainability and its engineering. How far have we come? So please join me in warmly welcoming Professor Patricia Lago.
So I don't see you, Guy, but I hope you see me. Thank you very much. You are too kind. And also the community clearly is too kind to recognize so many things. I'm humbled. Thank you for trusting me with this talk. For me, it's amazing to be able to share my perspective with my community. I also want to mention before I start two people that is always in my thoughts. One person is my late colleague and friend, Ivica Krinkovic, who is still a role model for me every day. And the second is Letizia Iaccheri. He's a friend and colleague since I was a PhD candidate. And she is always giving good suggestions to me, and she's a champion for all of us in research in software engineering and gender diversity. So the slides will be shared. Don't take pictures. Today I will share, so just relax and think. I also pre-warn that I will use some of our works to criticize it and see what we did wrong. And so if I use yours, please forgive me. A disclaimer, I can't pronounce the R. So I find with my students useful to warn you so that you can tune. Nothing to do about that. I was born that way. So first of all, your most urgent question, where is the Netherlands actually? It is a super tiny country in the northwestern part of Europe. I put some numbers there. It's about 240 times smaller than Canada, and consider about 90% of that is water. If you zoom in, you start seeing that. You zoom it further, you start seeing Amsterdam. The Vrije Universiteit Amsterdam is in the southern part of the metropolitan area of the city. It has a fantastic city campus, only one train stop away from the Schiphol airport, the airport of Amsterdam. Here is a recent photo of the city campus. Come visit us. In the middle of that, you have this L-shaped building. It's a smart energy optimizing building, and in the top 3 floors of that, you have the Department of Computer Science, where we are. This is the view from the main building of our university, the VU. This view is the Zuidas, which is the Amsterdam Business District. We are very lucky to enjoy a lot of collaborations with high-tech companies, financial institutions, consultancies, etc. So At last, this is our group. By the way, since this year, I co-lead the group with colleague Ivano Manavolta, and it's called S2 for Software and Sustainability. You had the pleasure, occasion to meet many of us this week. Each of us has their own research line with an important focus on sustainability in software engineering, from software architecture and quality assessment to software adaptation, ethics, robotics, green AI, etc. So we always have regularly, actually, visiting researchers that are with us and inspire us, and we get inspired. And so if you're interested, just I invite you to visit our website to get to know us better. So now back to the contents. The flow of my talk is along these 3 points. I want to spend very little time to emphasize the problem that we want to address in software sustainability, some of the symptoms and some of the causes that I find especially interesting to mention. Then I want to bring you in a time journey of where we are now and where we come from, and some of the future research directions that I think are very promising or very urgent to address in our field. Then I will summarize the takeaways, and if time is left, I will take the occasion and misuse the podium to reflect, to share with you personal reflections on our role as researchers, academic life, and a word of encouragement. So I beg the pardon for those that already work in this field, because in order to be on the same page, I will also share what I think is a good definition or connotation of software sustainability. So if you already know that, you can take a nap. Maybe after yesterday, we all need that, or maybe not, and then we have great discussion afterwards. So about the problem. So in the last decades, we enjoyed and witnessed an extreme digital transformation of global society as we know it. This brought a lot of opportunities for many of us. We can choose the country we like best to live in, economic growth, simplicity in lifestyle. But this brings also a lot of dependency in basically everything we do, every digital dependencies, in every sector, every activities we do. So not everybody is actually born with this type of digital transformation. In this direction, also digital innovation is not always fair. So there are many people, many societies that don't have access to that or cannot afford it. Digitalization also comes to a cost. The energy consumption of software-intensive systems is staggering, so much so that we need efficient technologies. We need a lot of infrastructures like data centers, powerful networks, powerful devices, and this energy consumption and this use of resources, which are becoming scarce, they are also fighting against the needs of the same resources for humans and the planet. Finally, decision-making, so the way we decide to invest in digital is not always based on rationale. On the contrary, it's often based on cool technologies that maybe we don't know yet what they're useful for, hype, fear. So we have to be aware that we contribute as researchers in these fields in one direction or the other. The symptoms are many if we care to listen. Planet Earth is rebelling. Digital technologies are actually prone to bias, discrimination, and misuse. So when we inject them in society, they are not neutral. And if we look at the predictions or the reports about the next global risks and the top one global risk for 2027, we see that misinformation and disinformation are at the top, driven by technologies, and also adverse outcomes of AI technologies. I promise, it's almost the last time I mention AI. So an example is this report, recent report of the World Economic Forum. I think it came out last month, talking about the AI and energy paradox. On the one hand side, you have a lot of investments in AI, so much so that the prediction of the estimation of the energy footprint of AI for 2030 alone is the same and even becoming larger than what was the prediction of the full ICT sector for the same time. So this is very worrisome. And at the same time, as I said before, not necessarily we develop AI technologies that is fulfilling the benefits that we think it promises, and in some cases, we don't even know yet which are these benefits. The causes, there might be many, I don't know. I want to frame two for our reflection. One is denial. There was this recent article on The Guardian of Robin McKee, which is the science editor for the past 40 years of The Observer, and he was reflecting that people quite often, too often, don't want to see the truth, even if it is brought by scientific evidence. And he mentioned things like climate change. And the other is a mistaken feeling of powerless. So I want, well, with some humor, I want to quote Dr. Goodwin of the Netflix series New Amsterdam, in which he changes the culture of the hospital only by showing that even one person can make the change. So these two feeling denials and feeling powerless should be overcome. So on the one hand side, we must take action. On the other side, we can do that, even as individuals. So if we look at the past, independently from software engineering, I think there are three important results that we use and can use actively to have a bigger impact with our research in software. The first is the dimension of sustainability. So many, who never heard about that? Who knows about that? Okay, and some undecided, very good. So the dimension of sustainability are many. There are plenty of classifications out there. I put here people, planet, and profit because it's one of the oldest. But basically, they correspond respectively to the social dimension, the environmental, and the economic. Then, of course, in software engineering, we care also of the fourth, which is the technologies or technical dimension. We find that in other classifications, for instance, the PESEL, which has that, is less commonly known, but also it adds other dimensions if they are relevant, which has the political and legal. The second result is the order of impacts. Effectively, is about time. We cannot talk in our research about sustainability if we don't consider the time. So this classification goes back to 2001. This is a foundational report that is not to be found online anymore. So thanks to colleague Lawrence Hilty, I archived that. So for anybody that wants to read it, just let me know. But essentially, we can classify time impact in terms of first, second order of impacts, or otherwise the direct, which for us means the sustainability impact of the technology itself. For instance, when we run a piece of software, the power consumption, the energy consumption, or the effectiveness, well, not the effectiveness, it's the performance of these artifacts. Then we have the enabling impact, which is about the processes that a piece of software is actually supporting, and we measure the process, not the artifact. And the third one is the systemic impact, which is the behavioral change that thanks or due to the use of software in society we triggered and caused. The last important results, everybody knows that, is the United Nations SDGs. These are 17 Sustainable Development Goals. They come with sub-goals or targets, metrics and indicators, and also online there is every year an estimate of how over 140 countries in the world are doing with respect to the SDGs. So it's very interesting actually to look at that. It's all online material, all the data set are actually open source. So if we move about software, of course, we can apply all these results, but to my surprise, the notion of sustainability for software, I think, is ill understood by many of us. A couple of years ago, I came up with this definition because I was looking for a definition that we can actually translate into what we are doing. And it has three components: the preservation in the long term, the beneficial use of software, and the last one is about context. It's a context that is continuously changing. It's like an independent variable. So we don't necessarily, or most of the case, we cannot control that, but it is influencing both the first two. What are the observations that led me to this definition? The first one is that most of the papers we published so far about sustainability or mentioning sustainability, they don't define it. I made the same mistake many, many times. Or if they mention a definition, they use the UN Brundtland Report definition, which is about the capacity to endure, basically comparing the current versus the future generations and talking about the impact on the planet. So it's about the social and environmental dimension, if you wish, with a systemic timeline. So it's about climate change and future generations. Of course, software engineering, allow me to say that, has a much shorter timeline typically, which can span from the development of a software project to decades in which we want software incentive systems to be actually technical, stable, or durable. So it's quite different. The second observation is that about this timeline, so it's not about the systemic, not necessarily the systemic impact, but is the preservation of the function of a system. So we are talking about what processes we want to support and the extent to which these are beneficial, and an extended period of time, which can be variable depending, again, on the type of software engineering project. The last one is, I have a belief that it is important to consider the balance over time of a certain properties or quality attributes of the software. It's a belief because in sustainability, the dimensions that we consider, they are not independent, and then formally, we cannot talk about balance of things that are not independent between one another. However, I come back to this notion of balance later on, and I think there is something there which I cannot yet identify, but I think is relevant to research. So my takeaway here is my definition is not perfect, but there is much more that we should consider. And if we do research in sustainability, we have also to reflect on how do we contribute in these different type of orthogonal aspects. Another way to look at these two perspectives, I don't want to spend too much time, but there is a difference between sustainable software, inward-looking, in which we are talking about the sustainability properties of software as an artifact, and software for sustainability, which is we have a piece of software not necessarily sustainable, but that is meant to support sustainable processes. What I like best is this other type of connotation. So to summarize, if we talk about software sustainability, I think we have to address both what I call the dimension of focus and the dimension of time. And we cannot talk about one, for instance, the first, and not the other. If we do that, we are not talking about sustainability. So for the dimension of focus, I have an example. Think about a drone. If we want an efficient drone, inward looking, we basically care about squeezing the software, optimize that technically so that it can control the device. And at the same time, we want it to be energy efficient in the environmental dimension so that it is not draining the battery. But we could, for instance, want to develop drones and use them because in medical emergencies, for instance, the supported processes in which we care about making, having economic goals like providing affordable healthcare to people, or the social dimension like providing healthcare emergency support to people that live in remote areas. So in which these other scenarios of type of project, we don't necessarily address the other two dimensions, but we want to assess the extent to which we achieve the economic and social goals. In terms of time, in the first example, we are talking about the direct time dimensions. So I want to assess now, to measure, carry out, for instance, experiments now of the energy consumption of the software in the drone. In the second type of projects, we want to measure again the impact of the processes, indirect over time, or even the systemic if relevant. For example, if we replace ambulances with drones, we make a change of the sector, but also we need the operator for emergencies to have different skills and competencies, which changes the way basically society is educating this type of operators in the healthcare. So we see that sustainability is much more complex than energy consumption and performance. Another aspect is rebound effects, or the Jevons paradox. It is also possible that, and very common in fact, that there are effects that we didn't plan for, so they are unexpected. They can be positive or negative. Typically, rebound effects are linked to negative ones. And you can imagine that if I develop drones which are very affordable for medical emergencies, and then society decides to turn drones, affordable ones, for toys for kids, then all the efficiency that I realize are negated. So we have a rebound effects because then you produce a lot of drones with a lot of sustainability impact only to give gifts. So this might be a type of unexpected effect. So one thing that I wanted to say here is that, to my knowledge, in software engineering, we hardly address rebound effects so far. Finally, digital sufficiency is something totally different than efficiency. So far, I'm talking about optimization and efficiencies. But it is also, there is a relatively recent line of research on sufficiency. I don't enter the details here, but it's basically about identifying when certain software incentive systems are really useful and should be used, or rather, they should not, or even hardware, for instance, technologies. So its sufficiency is about not optimizing what we produce, but assessing, for instance, if we should not produce at all certain technologies. An example of hardware is the recent regulation of the European Union, the right to repair. So by extending the life of hardware, actually we have to produce less hardware in the first place. Concerning users, for instance, is not only about creating awareness, but it's also in empowering the user, for instance, to decide when the use of certain software is useful or not. For instance, for focus work, we don't want to be 24/7 online, but also for what purpose. For instance, when we do collaborative type of work, we use technologies or services like sharing data or meeting software. But if we don't do such collaborative work, maybe we can work locally, individually, and not use software at all. And finally, we have the economic dimension. So the fact that not necessarily is about growth, but is also about being just enough about the economic goals, and maybe, for instance, working less and dedicating the hours of the day to care work or to other important aspects of our lives. Moving to the present, how far did we come? Well, I want to share this picture because maybe, well, many of you know already, but in the Netherlands, when we become a full professor, within a year, more or less, you are expected to give what we call the inaugural speech. So here we present to the general public what we do in research and what we plan to do as a professor. So this was about 10 years ago for me. And I went back to the material that I presented at that time, which clearly was about software and sustainability. I wanted to say, okay, how far did we go? And to my surprise, I could have used part of the material today. So my takeaway is technologies goes very fast, but is the same for our research. So what is the impact of our research in what we want to achieve? Well, in my case, I could have done much more, I think. So to present my reflection on the state of the art, I have this nice picture. I hope you're still awake. So on the horizontals, I have some aspects that I think, or area that I think we have both progress, but we can do much more. Basically, on the notion of sustainability in software engineering, on how far we've got for sustainability with software engineering, and my research is about software architecture, so of course sustainability with software architecting as well. In the verticals, the good, so what I think are really results that we achieved in research, the bad, what I think we started having some initial results, but we have to do much more, and the mystery, big research questions that we underestimate badly, I think, and it's really necessary. So to start with the notion of sustainability, I mentioned the dimensions of focus. I think there are two foundational works that influenced in the good and bad the way we look at sustainability in our field. One is the Greensoft reference model. I don't know how many of you know that, but basically it goes back to 2011. And as a reference model, by design, it is very abstract. So maybe this is also the weakness, or I think it should have been considered much more than it is already. The good thing is that it is, to my knowledge, and we are talking about over 10 years ago, to my knowledge, it was the first and only, if you wish, that already considers seriously the time dimension. So the three orders of effect mapped on the different phases of the software lifecycle. And as a reference model, it was considering also that we have to provide tooling, we have to provide knowledge about software engineering knowledge that needs to be reused, etc. So it was, I think, quite foundational and impactful at the time, and still nowadays. The second is a small work that was the result of the Greens workshops here at ICSE in 2013. And in a group, basically, we came up with this paper that was published, unfortunately, years later, that influenced the definition of these dimensions of focus. We meant well. I think that the influence went a little bit too far. There are also two major works that I think, these are all community works that consolidated their research incrementally in the last 10 plus years. One is the Sustainability Awareness Framework, the SUSAF. This works best in requirements engineering. And it basically supports a number of stakeholders, most prominently consumers and users, to actually frame sustainability in the domain they care about. And they talk about values and fairness and agency, discrimination. So how we measure, well, not we measure, but how we consider which properties of the software have an influence for these aspects. The second is the Sustainability Assessment Framework, SAF, toolkit, which works best by design in architectural design and decision making, and it frames software features and sustainability quality properties and translate into metrics and measures. So these two works they are both open source, anybody can use, extend, etc. The first one, the SUSAF, differently adds a fifth dimension, the individual one, naturally, focuses on let's say, the quality attributes that are important for the individual. And the second, it's added also the traceability from KPIs, metrics to software features. So in this way, focusing on requirements engineering, focus on architectural design and measurements. Basically, I think these two works, they developed two communities in parallel. They are strikingly similar. I think they should be merged because together they cover a much larger chunk of software engineering. On the bed, I see two aspects, two, let's say, research topics that need much more sound research. The first, I mentioned before, the dimension of time. So for instance, in both these two toolkits that I mentioned before, either the requirements or the qualities and features, they are mapped on the three orders of effects, but there is more an intuition than a solution. There is no sound way to actually consider seriously time in the way we frame these aspects of software. So we classify according to the time dimension, and that's it. So this needs much more research. The second reflection, and I go back to the role of the dimension of focus, concerns human factors. If you think about that, also if you look at ICSE and the SACE track and CHASE and a lot of fantastic research that we also heard and read this week, the traditional old-fashioned way to look at software in terms of technical quality attributes is now complemented with properties that are intrinsically in the social dimension. And this is normal, and this needs much more attention because, again, software is used everywhere in our lives. So it influences positively or negatively. So with a colleague of mine, a PhD student, we carried out the analysis of the last 10 years of SACE. SACE is this year, year number 11, and the SACE track. And what you see here is basically, while the SACE track initially was meant to be, was initiated to focus on sustainability, it naturally evolved to actually more and more, you see the trend, the continuous trend line here, more and more to focus on social aspects. And for me, this is the reflection that we have a lot of focus in the trade-off between the technical dimension and the social dimension. Still, SACE publications don't focus necessarily on sustainability, but if we leverage all these results that we have in the SACE research and other research in this domain to quality properties, and then we start to quantify or qualify the role of software with respect to these quality properties, we actually can design for socially inclusive and socially supportive software, more in the direction of a good sustainability connotation. We move about sustainability aware software engineering. I have one main takeaway here. I think looking at software as an artifacts, empirical experiments, I think we went very far. So only this week in this edition of ICSE, I counted over 50 talks and publications about energy, sustainability, carbon, environmental aspects. And we see also in our publications that the energy consumption of software-intensive systems is becoming more and more prominent. We know, most of us know very well how to design and execute empirical experiment. So we should invest much more in sharing this expertise with society, public, private sector, end users, etc. So I think we should invest in making sure that experiments are well designed and executed, that the results of such experiment are well described and not overstated, and that we synthesize the lessons learned and we share them so that they can be used and we can build a body of knowledge that builds upon the huge expertise that we built up in the last years. There are 3 works that I care to mention, also again, community works, also summarizing experience in decades, literally, of research. The first one is the Green Software Measurement Model, GSMM. It's 10 groups in 4 different countries, and basically in this work, these groups working only in the trade-off between the environmental footprint of software and technical properties, basically summarize different initiatives, different ways of designing and executing experiments in one unified model, which basically summarizes, give guidelines about how to carry out the different phases in experimentation and how to report about that. It's quite nice, I think. The second is a work with colleague Ivano Malavolta and Vincenzo Stoico. We have been teaching the Green Lab course at the master level for 10 years. So we summarize here our experience always in the same space, but how to basically invest in the new generation of professionals that have to bring these expertises. And I'm sure there are many others. So again, sorry for mentioning our work here. And the third one is also a very recent, let's say, recently pre-published work from colleagues from the University of Pisa on the carbon footprint of software design and development. So this work is really interesting. I bring here only an example. It has a very rich set of highlights and takeaways, and in this example is the reflection only about the fact that in research we care about the carbon footprint and the perspective of the software developer, but we need to achieve environmental sustainable software by involving, engaging different stakeholders with different expertises, and especially mention software architect and sustainability engineers. What is the bad here? Maybe I hinted a little bit, but I think what we need to invest even more is to think about what is a sound, scientific, grounded societal impact that we want to create. In sustainability, it's not anymore about publishing, it's about how we communicate and have our know-how adopted. And I have 2 ways to do that: knowledge synthesis and sharing, and sound measures. First example is few organizations. These are mostly professional organizations. There are many more. Prominent companies and researchers are members of these organizations. So we should, as a researcher, not only participate and gain visibility and maybe carry out some experiments, but we should influence them so that the results of this organization have a scientific foundation. We try on the right-hand side with this archive. It is a number of years that we have, is open source. In my idea originally, it was simple enough to be well received by industry. I think I'm failing badly here because it's not used very well. So I think we should not only share open source, but also think about how we communicate in a way so that it's attractive, because society wants to use good practices, so we can share much more. The second example is standardization. We are in an age in which finally society understood the importance of software. There are two standards that are only about software. The first one, many of you know that it is a recent standard, the software carbon intensity, SCI. It's a nice formula that frames how we could actually build metrics to measure the carbon intensity of software. It's very general by design because standardization is a compromise exercise. So everybody, all companies must fund themselves in this. Therefore, the level of abstraction increases. And therefore, when I measure and you measure using the same standard, we measure differently, and then we get a number and we compare, which is obviously not a sound way to do that. So we should actually influence these standards to provide embodiment with concrete metrics for application-specific, domain-specific, I don't know, anything is useful so that these concrete metrics are used, applied, appreciated, and then leveraged to a good practice in society. The second standard is the resource-efficient software. This is not a standard yet. In fact, next week there will be the third round of workshops to actually build it, but it's a good thing that these standards are coming up. So what we can do here is, I think we have enough knowledge and research to build, for instance, benchmark that can be reused by practice. Here again, we have an example of an excellent benchmark for resource-efficient software. And we should actually complement all these initiatives with our research. Finally, about architecting. In general, in software architecture, we have a very mature body of knowledge that is mature, is consolidated, is reused. So I mentioned here 2 books and a standard. The first book is the classic Software Architecture in Practice, 4th edition. The second is Architecture Knowledge Management. The third is a standard, the 42010 on software architecture description. So again, my reflection is concerning the standards differently from the metric standard we saw before. This is well received by society, is applied, and the last edition was in 2022, which revised a little bit from the previous one, which was 2011. And still, we can reuse a lot of things from this standard also for instance, ethics and sustainability without any change. For instance, design concerns, as quality concerns, the notion and the role for architecture elements, architectural views, etc., basically remains the same, only we have a new challenge. In the Architecture Knowledge Management book, actually it summarizes nicely that we have a lot of artifacts in architecture that can be made explicit. So we have some explicit versus remain tacit in the head of the people, or that are meant to be application specific or application generic. The observation here is that we have a lot of these artifacts, tactics, reference architecture, design patterns, etc., etc. How much of these are being actively adopted in practice, therefore in society? Not many. One example, why is that? Because they maybe don't fit in the way companies or organizations work, or maybe they are too complicated or require too much investments. I don't know, there are all types, well, all that I mentioned could be valid, but when they are adopted is because they are simple, beneficial, and usable. A classic example is the architecture description record. It's very simple, and it summarizes architectural knowledge elements like concerns and design options and design decisions and qualities that come forward for any type of system. I have here two examples from companies we work with that are basically an extension, if you wish, of IDRs. One is the decision story from CGI, the other is the solution intent from ABN AMRO Bank in the Netherlands. Basically, they are different. One provides guidelines, the other provides, for instance, the difference between compliance and deviations from architectural standards, obviously because they have to comply to laws and regulations. But essentially, they are simple, beneficial for the practice, usable. So how can we do the same to actually bring society, organization to adopt much more sustainability goals in the way they develop and maintain software-intensive systems? I think the same principles should be applied. I have two examples in which we are trying to experiment with these things. The first thing is to combine the state-of-the-art in software architecture in one side and industrial practices on the other side, and try to carve the state-of-the-art where is beneficial in the current practice, so that you bring with you organizations. And to do that, colleague Markus Funke, he basically identified, together with the architects, a number of recommendations on how, on the right-hand side, you see in the green, the state-of-the-art, and the color elements on the other side are the practices that the company already has, and then try to embed with the lines which state-of-the-art elements could fit. And he identified a number of recommendations together with the architects and IT professionals to actually embed this, so how to bring them in this transition. So in this way, we can help them, organizations, to apply sustainability principle in a scientific and sound way. The other example, very quickly, is a very promising work of colleagues in IIT Hyderabad. Basically, they tried to use the collaboration with industry and their context and their practices, and they are building Arcbench, which is an open source project, extremely interesting, in which basically they apply LLMs, second time I mentioned AI, LLMs to learn from the design decisions and the design practices that they consider in the organizations, build support for architects and developers in changing these decisions. And they have a work in progress. What is important to mention here is not only about precision and recall, not only about energy or resource efficiency, but also, for instance, other things like developing SLMs for specific to a company, so that the architects can work in-house for sovereignty purposes, but also can have flexible work so that they can also have more sustainable way of working. What needs more research? I think it needs more research following standards, concrete measurements, etc., quality evaluations and quality assessment. We started like this, a little bit. However, based on architecture assessment methods, which are fairly mature nowadays, we identified two major challenges in sustainability in software engineering. The first one is that we don't have two quality attributes to measure and make trade-off. We have both multiple dimensions of focus, and for instance, economic and technical dimension. And within those dimensions, we have a complex network of different quality attributes for each of these dimensions. So the indicators that we have to build are much more complex, as well as the traceability to the architectural artifacts. We again started to do that. Many more researchers, I think, have to work in this direction. This is extremely interesting. In this example, colleague Ifat Fatima, she basically took the economic and technical dimensions, prioritized with architects the quality attributes within each, and then she is able to produce a number, these indicators, that is basically quantifying the sustainability impact in the dimension that has relevance for one design option, in this case, containerization, yes or no, with respect to the theoretical optimal. There are many more mysteries, things that I think we can go in many different directions. You don't have to know this, don't worry. I here use the meta model of the SAF toolkit. You know this by now already. You see in yellow the dimensions of focus, the dimension of time. We represent in the middle in white-ish the architecture elements. On top in blue you have metrics, measures, goals, indicators. And in red on the bottom you have the contextual factors. So one future major research topic, I think, is what I call systemic design. The reflection here is that when we measure quality attributes, so far we classify them in some dimension of focus, but in fact, what we should also combine is the measures for both the immediate impact versus the enabling impact. For instance, the immediate impact is the energy or power consumption. If we optimize that, it's not enough, because the question is, for what purpose? An optimal piece of code not necessarily sustainable. It is sustainable if it has a positive, the optimization has a positive impact on the target benefits. For instance, the benefits of use, which is the enabled processes. So in order to measure sustainability, we have to consider both direct and indirect effect and the trade-off among them. Another important element for future research is the role of context. Context is often mentioned, is by and large left unknown and overlooked. Context also is changing over time. And when we talk about sustainability, we have to consider context. So Lionel and colleagues already make the case about context-driven software engineering. I think there is something important there, because context is usually implicit, so tacit. So if software architectures are dependent on the context and this changes over time, we have to design for it. This reminded me to summarize time and context, the recent editorial of colleague Bashar Nozebe. It's one of the best reads of this year for me. He presented yesterday Context 2.0, but I think the way he phrases the importance of context in society in this piece is fantastic. So the summary in this illustration here is that so far we focus on the dimension of focus, we neglect time and we neglect context, and sustainability has to address both of the three simultaneously. So if I put together the work of Bashar and the definition I try to put forward, I think this is the message for me for a big gap in sustainability in software engineering. Last 2 points. One is about traceability. We assume in our research traceability, but if any of us works with practitioners, it's not there. It's important, it's impossible to have sustainability by design if we don't have traceability about the impact, the role of a piece of software for certain sustainability targets. So the green part says here that if you have a sustainability goal, you have a certain metrics and measures to measure that, and then we get a number, and this number is reflected in the design decision that we take. We have to trace this decision to the architecture elements, modules, components, features, services, whatever, so that if we are not happy about that, or if we are, we have to trace back, so change the decisions and see what happens. So without this cycle, it's impossible to design for sustainability. Finally, I already talked about balance. Balance is about basically all these measures, but try to stabilize them within certain min-max boundaries over time. So if we don't have this stability, again, I don't think we can talk about sustainability. Here we tried to inject this stability by using software adaptation to basically, when we see something that is going beyond the boundaries, then we adapt the software to bring it back within the boundaries. This could be a way of looking at that, but maybe there are better ways. Finally, I said in the beginning about the problems. We have a lot of technologies out here. There is a frenzy about AI, first time, AI and data centers. The world is actually has limits. I don't want to go to numbers. There are many different numbers. None of them is actually looking good. But at the same time, we forget it's not only about technologies and energy or carbon intensity. It's about the purpose for supporting and improving society. Is about human values and inclusivity. So going back to digital sufficiency, we shouldn't invest only on efficient data centers and cloud and algorithms and technologies, but also how do a sufficient software look like? For instance, a sufficient cloud that is actually not providing services under certain circumstances, or is actually shutting down parts, or we don't even have to build certain data centers. And how does a sufficient software architecture look like so that certain features or certain functionalities actually shouldn't be used, and they empower the end user and the consumer to actually follow these guidelines? I think I don't have the answer to this. We explored some scenarios that goes from cloud centralization to geolocation. There are many different follow the sun, follow the energy ideas and promises. I wanted to quote this work from colleagues in cloud computing and distributed systems. We all know that infrastructure provides awesome opportunity for optimization and load balancing and geolocation. But in software engineering and software architecture, do we actually provide this flexibility? I don't think we do, because even works that I followed this week or I read about, they are more about the infrastructure services than the software applications. So I'm talking about questions in which at the endpoint, so in our end devices, we can have applications that optimize latency of energy efficiency. But then, for example, if these applications are reused in a community, for instance, a local community, we can move to the farther edge or fog nodes part of these components. So the architecture itself should be flexible to actually geolocate and reconfigure seamlessly depending on not only availability of energy, but also on the type of functionalities that we have. For example, even AI-based applications, if the mature language models is actually reused by a community, then we could actually have in the edge and not in the further cloud, because the further cloud, the hyperscaler, would need also a powerful network in order to have data exchange. So there are many opportunities, and what I have here in the green boxes and rounds, basically software architecture and software engineering is not yet providing this flexibility. We have also a lot to learn. Here are two community works on the state of the art in teaching about sustainability in software engineering, and also an industrial study about what industry needs. And they actually know exactly what they are missing. And I think here there are many opportunities to actually design our education in software engineering more effectively, to avoid that we make decisions not based on the good reasons. In summary, I discussed things that I think are mature enough and a lot of things that require much more research. So this is good for our research business. I want to summarize here many of these aspects because I think we have a lot of opportunity to be much better in the way we address sustainability in software engineering. Maybe some of us, like me, discover I didn't do much, and maybe some of us discover I was actually doing research in sustainability and I didn't know that. I misuse, in the end, my one millisecond or 100. Again, in the Netherlands, at least as far as I know, there are some universities that when you get your PhD, you also have what we call the propositions, which are 10 statements that after 3, 4, 5 years of research, you want to reflect upon your research. And typically you have some which are directly related to that and some others that are indirectly and some that are totally unrelated. So I want to mention two, and I share the material so you can think about that and then shout against me offline. Number 8, thinking time over publication frenzy. I think we should publish less and do much more research. This goes back to my reflection of my earlier lecture. If I was publishing less, I could have contributed much more sustainable and sustainability-aware research in my interest. And the last one is a word of encouragement, Italian, volere è potere. So where there's a will, there's a way. I think we can do also as individuals much more. Thank you.
Thank you very much, Patricia, for the excellent keynote.
Thank you very much.
So we have time for some questions. So you can use the microphone at the back of the room to ask your questions. Yes.
Thank you very much, Patricia, for this very nice and overview over the state of the art and where we still have things to do. I wanted to add 2 points here. One data point, the International Energy Agency, who is coordinating the efforts, the national efforts to secure energy. They have cooling, electrical vehicles, and artificial intelligence as the main consumers that will threaten the energy systems in the next 10 years. So I think in a way somehow artificial intelligence made it all the way up to the top there. The other thing is that there's some people in the information systems who start to discuss not organizational IT transformation, but societal IT transformation, because we don't have actually the concepts to think with, the tools to think with when we look into big societal infrastructures and how they actually affect the society. So there's kind of like sustainability, the social and economic, and also the energy sustainability of societies. And I think we have to develop a better understanding of these dynamics. And
Yes.
there's a lot to do also for both social scientists and computer scientists.
Yes. Thank you for the comments. I fully agree with you about the first aspect. Yes, this is a generalized trend. I mean, it's a fact, in fact. So AI is becoming #1 energy consumer. This goes back, I want to counter comment, not necessarily should be that way. So again, it's not about efficiency, it's about sufficiency. So what is the benefits? So we should think about that and question that. The second aspect, I fully agree. So this goes in the direction of imagine types of new tertiary studies that build upon all these platforms and these researches or developments that we did for societal impact. And then we could, based on those, study what are the sustainability quality properties in the societal impact that we learn from that. And then we frame these in a sustainability KPI in which we basically say, okay, how far this platform, for instance, could actually achieve the promise for a social sustainability impact. I think there are a lot of researches that already could provide the foundation for these follow-up studies that actually synthesizing this knowledge in something that is really more impactful.
Thank you, Bill. Thank you very much.
Out.
Okay, great. Thank you, Patricia. Ina Schiefer-Degge, Berlin. I wanted to ask you about the relation to hardware and to data. So what's your take to make digital infrastructure and services or digitalize infrastructures and services sustainable?
Yes. Yes, a lot have been done already, but the point is that there are a lot of tactics, good practices on, for instance, how to, depending on the profile of the software applications, which is also a line of research, a research question, I think, you could exploit the computing resources, hardware, much more effectively. And tactics also, some are very well known, some are also adopted to basically switch off hardware, but also to consolidate similar applications or complementary applications in different type of virtual and physical servers. So the interaction between software and hardware, I think, can benefit of better practices and tactics to actually be also more sufficient. About data, it is amazing that numbers say that about 98% of the data managed in data center is what is called dark data, which is data that is never used. So this is consuming actively a lot of resources that are wasted and taken out, for instance, from society. A few days ago, there was the shutdown of the Iberic Peninsula. I mean, that's amazing. And this is becoming more and more frequent. And maybe we can optimize or make sufficient also technologies like data so that, they consume it all. And I want also to mention data traffic. So there is a lot of experiments that we carry out in which we neglect data traffic. But if we execute locally versus remotely, well, there is a difference because remotely comes with a lot of data traffic. Also tactics there, especially in the age of use and misuse of AI technologies. Also there we can optimize the amount of quality data that we actually use. So a lot of things have been done, but not consolidated.
Thank you.
Thank you.
I want people to think about practitioners and industry, where the context today is about being agile. We deliver fast, we learn and adapt. So this gives us an opportunity to introduce and improve sustainability, but it also gets us too busy to think about sustainability. So it's an opportunity and a challenge.
Yes.
And the research community has to help industry deal with that dichotomy.
Yeah. I agree with you. Good comment. There are countries that by and large don't find sustainability as a priority. However, I think that it's also a business case, a very important business case for industry, actually to provide an alternative technologies or support for sectors which is considering sustainability properties. Yes. Thank you.
The last question.
Yeah, thank you. Thank you for a great presentation. Yeah, I'm sure that there is a good reason why all the slides come with dark background. Yeah, if there's anything, please let us know. And Mike, during this talk, I was trying to listen as a junior developer who want to take and apply in their own practice. And what I learned that you beautifully mentioned that at this point, time and context also important. And
yes.
If I may, I would add audience here because, you know, as a junior developer, they have different background, they have different, you know, capacity of the knowledge, and now they want to apply these, concepts into their own practice. And when we think about from this perspective, we understand, you know, talking about sustainability from a very high level is maybe just interesting for managements, but when we are, you know, involving developers is going to be challenging. What's your opinion on this?
I fully recognize your comments. I agree. My experience with collaboration with industry is that what works well is the individual which officially or unofficially acts as a champion. So even as a junior developer, you can make noise about the importance and the relevance of sustainability. And I agree, looking for how to carve in your own practice beneficial small building blocks that make a change. And then this grows in the organization, so much so that I saw many organizations grow from it's totally relevant to sustainability programs internally and really being impactful and being recognized for that. So I'm more optimistic when I was talking about we can actually, as an individual, take actions. I really believe it. And it's up to you in your organization to start thinking, talking with the researchers if you find it's valuable, exchange idea. We can discuss offline with the coffee, but it is possible. I saw that happening.
Yeah, absolutely.
And also researchers, they have to listen better. I mean, synergy with industry means also to listen about what is really useful and usable, not just here I am and my research is awesome.
Yeah, wonderful. Thank you.
So let us thank Patricia again for the insightful talk and discussion. Thank you. Thank you very much.